So we're going to go ahead and jump over to the Common Core website, as we always do at the beginning of a new grade. We're going to go ahead and jump over to the Common Core website, and I am going to go through word for word every single expectation that your child or your student will have to contend with or will be expected to understand by the end of their 4th grade year. Let's get started. Okay, so here we are, grade 4, introduction. Now, let's just go ahead and read through this. I will try, as I always do, to keep my commentary to a minimum until I'm done reading through most of this. Of course, this is me we're talking about, so I will probably end up interjecting my commentary anyway, and let's be real, that's why you come to this stream anyway. In grade 4, instructional time should focus on 3 critical areas. 1, developing understanding and fluency with multi-digit multiplication and developing understanding of dividing to find quotients involving multi-digit dividends. There was a lot of vocabulary there. Quotient, as you may recall, is the answer to a division problem. Dividend is the thing that you're dividing. So we're going to be focusing on dividing multi-digit numbers into smaller numbers, essentially. Number 2, developing an understanding of fraction equivalence, addition and subtraction of fractions with like denominators, and multiplication of fractions by whole numbers. So in this, you are not having to deal with common denominators or finding them yet. That is, I think, in 5th grade. Right now, we are sticking with fractions of common denominators when it comes to adding and subtracting. 3, understanding that geometric figures can be analyzed and classified based on their properties, such as having parallel sides, perpendicular sides, particular angle measures, and symmetry. Big deal, lots more vocabulary. You know, that's a lot of geometry is vocabulary at this stage. Okay. So going more in depth, 1, students generalize their understanding of place value to 1,000,000, understanding the relative sizes of numbers in each place. They apply their understanding of models for multiplication, equal-sized groups, arrays, area models, place value, and properties of operations, in particular the distributive property, as they develop, discuss, and use efficient, accurate, and generalizable methods to compute products of multi-digit whole numbers. As always, friends, the Common Core folks are really, really great at making curriculum. They are not great at communicating that curriculum. Absolutely, totally understand that frustration. What this is saying, essentially, is we're going to use all the patterns about multiplication that we've already learned, and we're going to show how place value and multiplying by 10 are really the same thing. When we say moving to the 10's place value or increasing by an order of magnitude, we're talking about multiplying by 10. And we're going to talk essentially about how multiplying and dividing by 10 just involves moving a decimal point to the left or right, or any other power of 10. Depending on the numbers and context, they select and accurately apply appropriate methods to estimate or mentally calculate products. They develop fluency with efficient procedures for multiplying whole numbers, understand and explain why the procedures work based on place value and properties of operations, and use them to solve problems. Again, it's really important to note that we are really going to be leaning hard into the, okay, now you know the number, you know the answer, tell me why. Ain't nothing but no. Tell me why you know what, or tell me why you know what the answer is, and that's what we're going to be doing a lot of. Students are going to be expected to get fluent with the language of mathematics so that they can tell the teacher why they have the answer they have, so that they can talk to each other about the answers that they have, and so that they can pick out their own mistakes and mistakes of others. Very important stuff, and it's often overlooked when teachers aren't really leaning into the Common Core values. Let's see. They select and accurately apply appropriate methods to estimate. Oh yeah, we already did that. Oh, no. They select and accurately apply appropriate methods to estimate and mentally calculate quotients and, very importantly, interpret remainders based on context. So when you divide something into even groups, you don't always get a nice even number, right? Sometimes there's some left over. So we're going to talk about those remainders, and in a word problem, that remainder might be a pile of change sitting on the table, or it might be something completely different. That's really important. And being able to take the remainder and connect it to real world context is going to be really important. Number 2, students develop understanding of fraction equivalence and operations with fractions. They recognize that two different fractions can be equal. For example, 15 over 9 is equal to 5 over 3, and they develop methods for generating and recognizing equivalent fractions. Students extend previous understandings about how fractions are built from unit fractions, composing fractions from unit fractions, decomposing fractions into unit fractions, and using the meaning of fractions and the meaning of multiplication to multiply a fraction by a whole number. Again, we're not doing the common denominator thing yet. That comes later. For now, we're just saying, hey, here are two fractions that are the same. 15 over 9, 5 over 3. They're the same fraction. They look a little different, but they are the same fraction, and that's sort of the important thing. And a unit fraction, as you may or may not recall, is simply a fraction that has a 1 on top. 1/2, 1/3, 1/10, 1/millionth. All of those are unit fractions. And then to get any other fraction, you take a unit fraction and multiply it by some number. I have 5/4. 5 times 1/4. Number 3, students describe, analyze, compare, and classify two-dimensional shapes. Through building, drawing, and analyzing two-dimensional shapes, students deepen their understanding of properties of two-dimensional objects and use them to solve problems involving symmetry. So again, like with everything else, we're going to take the vocabulary we already know, we're going to increase our understanding of words we've already used, and we are going to learn new vocabulary words to describe more finely the shapes that we already all know and love. We know what squares and rectangles and pentagons are. We know what all of these shapes are. Now we're going to come up with more nuanced vocabulary to talk about specific aspects of those shapes. And it's going to be, it's going to be necessary if we're going to want to talk about what these shapes do and how they react with each other. So, grade 4 overview. Let's go ahead and just do a quick breakdown. Operations and algebraic thinking. Use the 4 operations, addition, subtraction, multiplication, and division with whole numbers to solve problems. Easy peasy, just like we've been doing since probably first grade. Gain familiarity with factors and multiples. A factor is just something that's being multiplied by something else. Same deal with a multiple, right? It is some number that has been multiplied a certain number of times. Generate and analyze patterns. Patterns are so important in Common Core. So much more important than answers. Number and operations in base 10. Generalize place value understanding for multi-digit whole numbers. Like I said, when I was a little kid, I didn't understand how base 10 worked. At this point, folks should. At grade 4, you should recognize that the numbers can get as big as you want them to be, or as small as you need them to be. Although we haven't really talked about decimals or negative numbers yet, but for now, like 3rd or 4th grade is where students should really realize that the numbers don't end. There is no highest number you can continue to tack digits on forever. Use place value understanding and properties of operations to perform multi-digit arithmetic. So again, adding and subtracting and multiplying and dividing multi-digit numbers, sometimes using a piece of paper if that is what is best, and sometimes using an array of mental tricks that we've already been talking about depending on what works for a particular situation. It's okay to have a lot of diverse options when it comes to how to solve a problem, so that you can apply the best option to the best to each situation. Number and operations, fractions. Extend understanding of fraction equivalence and ordering. Build fractions from unit fractions by applying and extending previous understandings on operations of whole numbers. This is so key. Oh my God, this is it. This is all of it. We want students to see that fractions work the exact same goddamn way that ordinary whole-ass numbers work. They both work the same way. And by comparing unit fractions to ordinary, like, whole number addition, we can hopefully at a very early age get students to realize that fractions aren't special. They're not like super scary. They're not something horrible. They're just regular, ordinary, plain numbers that act the way regular, ordinary, plain numbers act. And hopefully, if a teacher is good and talented at this, and hopefully I am, hopefully we can get students to get over the fear of fractions that so many of us still have at an early age. Understand decimal notation for fractions and compare decimal fractions. I don't know what a decimal fraction is, but this is the year that we're going to start talking about decimal points and, place value of less than 1. So, 1.24 or whatever. Measurement and data. Solve problems involving measurement and conversion of measurements from a larger unit to a smaller unit. This is important that is specifically from a larger unit to a smaller unit. Because one of the big sources of confusion when it comes to saying, I'm going to convert from feet to yards, right? But do I multiply by 3 or do I divide by 3? I know there are 3 feet in a yard, but because I'm American, do I multiply or do I divide? In this case, in 4th grade, we will always be multiplying by whatever the conversion factor is, because we are always going to be going from bigger unit to smaller unit. There are, for some reason, 5,280 feet in a mile. So we will be asking students to take 5 miles and figure out how many feet that is, but not the other way around just yet, is what I'm trying to say. Represent and interpret data. We've already been doing bar graphs and picture graphs and a bunch of other stuff, so we're going to continue that. Geometric measurement. Understand concepts of angle and measure angles. Wow, I flubbed that whole sentence. Let me try that again. Geometric measurement. Understand concepts of angle and measure angles. So we're going to start figuring out a new measure, right? Figuring out how many degrees an angle is something brand new. Maybe we're going to start picking up a protractor. Who knows? Geometry. Draw and identify lines and angles and classify shapes by properties of their lines and angles. So we're going to start talking about parallelograms, and we're going to start talking about other shapes that are defined by parallel and perpendicular lines and other various angles. And of course, as always, the 8 mathematical practices that I'm always going to read at the beginning of every grade, because every single grade focuses on them in their own way. Number 1, make sense of problems, persevere in solving them. Number 2, reason abstractly and quantitatively with numbers. Number 3, construct viable arguments and critique the reasoning of others. Number 4, model with mathematics, relate it to the real world. Number 5, use appropriate tools strategically. It's not enough to just get the answer. You should be able to tell me how. Number 6, attend to precision. Say what you mean and give the answer you mean to give. Number 7, look for and make use of structure, patterns. Number 8, look for and express regularity in repeated reasoning, which is going to be really important because the relationship between 100 and 1,000 is the same as the relationship between 1,000 and 10,000. 10,000 and 100,000, 100,000 and a million. Being able to use those patterns is really important, and it's what really opens up the place value system and numbers in general, so that you can make a number that's as big or as small as you want. So that, my friends and students, is the introduction to 4th grade. Now, we've been doing this for only about 30 minutes. I'm going to go ahead and pause the stream really quick because I feel like I have been out of breath for most of this. And I think it's just because I have been talking an awful lot very quickly. So I'm going to give myself a quick breather. I will be back in 1 to 3 minutes. And then we are going to start doing some math. So I hope you'll stick around. Be right back.